r cube is proportional to t square. I call Kepler's rule because Newton called it Kepler's rule. Newton learned about this in astronomical textbook, and he immediately understood its importance. And in fact, Newton's Principia is based on Kepler's rule to this, not on Newton's force. That's why I like to look at Newton's corollary 6 of proposition 4 in book 1. So we can write Kepler's rule like this or like this. It's as a ratio and it's constant, or like this, r over t square equals 1 over r square, the way Newton wrote it in this case. To make calculations with this proportion, we need 4 terms. So we first choose unit terms, and then we compute other properties of other objects. So for instance, r naught cube, r naught may be the astronomical unit, the distance between Earth and the Moon, and t naught may be the Earth's period. So this stays constant. This is the constant term, and then we can compute the radius or the period of any other planet. So let's look at corollary 6 of proposition 4 in book 1. So Newton first states Kepler's rule. If the periodic times vary as the 3½ powers of the radii, so this is exactly Kepler's rule. Like this, the periods, or yeah, we need, you can write as like this too. So we can, this is what Newton states, the same thing as the rest. So if the periodic times vary as the 3½ powers of the radii, like this, 3½ powers of the radii, the periodic times vary as the 3½ power of the radii. So we can write this like this too, and this one Newton does. He writes it like this. And then the centripetal forces, so he calls this part centripetal force, even though it has units of acceleration. I guess for Newton, acceleration is force, or force causes acceleration. Centripetal forces will vary inversely as the square of the radii, and he calls this 1 over r square as the way this, what he called force, varies. So Newton is just labels Kepler's rule with his own dynamical labels like force, and there's no force term, just what Newton says verbally has force. Another problem is that this, so Newton is saying that this force is varying as 1 over r square. But this is not true. As this r changes, this r must change too. So this whole thing stays constant. There's another r here. So this is not an isolated rule. The Kepler's rule is the rule. This is not a rule. This alone is not a rule. And for the force to change like this, you need a time term here. Time must change for this force to change like this, but this t is the period, not time, not the unit time, not the changing time. This is fixed. This is the period of the orbit. So here we see clearly that Newton uses Kepler's rule. He assumes Kepler's rule. He writes it down as Kepler's rule, but he hides this fact by labeling the terms force. But I don't see any force term here. So the problem is here. So Newton assumes that if there is 1 over r square, there must be force. So we'll look at this more in detail later.